Hey everyone, I'm back with another problem on the InterviewBit series for the topic arrays. So the problem today is partitions. So you are given an array. You need to count the number of ways to split all the elements of an array into three contiguous parts so that the sum of all the elements in each part is same, right? So let's say you have an array and you need to divide it into three contiguous parts, right? So this would be one part, this would be another. So this would be part 1, part 2 and part 3. Contiguous means continuous, right? So the sum of this first part S1 should be equals to S2 should be equal to S3. They all should be equal. So you need to find the number of ways to split, right? And you're given the size of array could range from here to here and the elements would be from here to here, right? So let's take a test case to understand this problem better. So here the size of the array is 5 and we are given these elements. So we need to basically count the number of splits so that the sum of all the parts of the three parts which we would divide the array in should be equal, right? So the first thing which I can do is let's first calculate the total sum, right? How will we do that? So the total sum is equals to 9, right? So if the sum has to be equal, right? I need to divide it into three parts first of all, so that S1 is equals to S3, S2 is equals to S3. So the first thing which I'll be checking is if the total sum is divisible by 3 or not. Because I need to divide the array into three parts, and if the sum is not equal to or it's not divisible by 3, then there is no point because it is not possible, right? So is 9 divisible by 3? Yes, 9 is divisible by 3. So we'll calculate this sum. So I'll say S is equals to 9 by 3, which is equals to 3. So I need all the sum for all the three parts is equal to 3, right? So the first approach which comes to my mind for dividing the array into three parts is obviously iterating through all the possible subarrays, right? So what I can do is I can maintain three variables. I can start with an I, right? I can start with an I can start with a J, and I can start with a K, right? So I'll have three variables and I'll be iterating. So one subarray would be from 0 to I, and one subarray would be from I to J, and one would be from J plus 1 to K. So we got all the three subarrays, right? And I'll calculate all the possible sums for S1, S2 and S3. And finally I can check in if S1 is equals to S2 is equal to S3, then I'll increment my answer, right? So this is one approach, but what is the time complexity? Since you are trying all the possible combinations and we are looping through the array in a triple order fashion, so this would become O of n cube, right? Because we would have to use three for loops to get all the possible combinations for the subarrays, right? Okay, but this won't work, of course. So let's try to optimize it. So when I first divide from 0 to I, then I to J, then J plus 1 to K. Then one iteration I do is to calculate the sum, right? Can we reduce this step? Can we reduce the step? Yes. What I can do is I can maintain a prefix sum, right? I can maintain a prefix sum for this array, which would be 1, 3, 6, 6 and 9, right? I would maintain a prefix sum for this array. Now what I can do is I'll start iterating again, right? So I'll start from here, I, okay, and J would also start from here, right? Now what I can do is I already have the prefix sums. So one of my sum S1, let's take S1. So S1 is going to be the sum for this particular array from 0 to I. Okay. And S2, so it would be the sum from 0 to I. And S2 is going to be the sum from I to J, or you can say J minus 1, right? So I to J minus 1. And what would be sum 3? Sum 3 would be equals to the prefix sum from J plus 1 to N. Okay. So we are just using two variables here just to iterate for the subarrays, and we have already stored their sums, right, through prefix sum, because we have pre-calculated the prefix sums and have stored it there. So we won't have to use one more loop for calculating the sum. Okay, right. So how have we reduced it? How well we did as compared to the previous case would be, since we are only using two variables for iterating, so we have made it reduced to O of n square, right? Perfect. But can we do better? And here the space complexity is O of 1, but here the time complexity is this, and the space complexity is O of n, since we are using the prefix sum. Okay, but can we do better is the question, right? Can we do better is the question. Let's first take this array, right? So it was 1 2 3 0 3. Okay, so it's 1 2 3 0 3. So let's think about it. So the first thing which we can do is calculate the total sum, of course, which is 9. If 9 is not divisible by 3, then I do not have an answer, right? I cannot split this array basically, right? So if 9 mod 3, so it is 0 for currently. So let's say my target sum is going to be 3, right? Perfect. So what I can do here is, let's try to maintain a suffix array for this. Why suffix array? We'll understand that. So let's maintain a suffix array of size n, which is 5. Right. So the first thing, what do I have to calculate? S1 should be equal to S2 should be equal to S3. So why am I maintaining the suffix arrays? I'm trying to first sort this out, and I need number of ways. So I'm trying to first sort this out. Then we'll think about these two later, right? But first let's sort this out by calculating the suffix array. So let's maintain a variable sum, okay, which is equals to 3, since we want the sum to be 3, right? So now let's iterate from the back, and we'll check at every point. Okay, so this is 3. All right. And let's maintain a variable called s is equals to 0. We'll iterate from the back, so this becomes 3. And if this sum is equals to my target sum, let's call this sum as the target sum. If s is equals to target sum, then I can place 1 here. Why will I place 1 here? So that it denotes that from n minus 1 to I have a way. I have a way of getting the sum as the target sum, right? So I'll place 1 here. I'll go to 0 now, right? What is my current sum? It is 3 again, right? So I can place 1 again here. Okay, let's move forward. So now the current sum becomes 6. Is 6 equals to 3? No, my current sum is not equal to my target sum. So if you have a way, just represent it as 1. If you do not have a way, just mark it as 0. Just mark it as 0 for now. Okay, now let's move forward. So this becomes 8. Again I'll have 0. This becomes 9 now. Again I'll have 0. Okay, so what does this suffix denotes? This suffix denotes that from starting from n minus 1, I until this index I have a way to split the subarray such that my current sum is equals to my target sum, which is 3, right? But this is just a denotion, right? One only denotes the way that there is a way, but I need to count the number of ways. I need to count the number of ways. So I can start iterating from the back from this suffix marker array, and if I add from the back, I'll get the number of ways to split from the back till the index I'll get the number of ways to split, right? So let's just make it. So let's try to add in the suffix array. Let's try to add all the things from the back. So it is 1, so this becomes 1 only, and this becomes 2, this becomes 2, this becomes 2, and this becomes 2, right? Great. So I've got starting from n minus 1 to any index I. What are the number of ways to split my array from n minus 1 to I? What are the number of ways I can split such that my current sum would become target sum, which is 3? So the suffix is sorted now. Now let's figure out these two parts, which are for S1 and S2. S1 and S2, right? So how will I do that? How will I do that? Right. So since I've got the number of ways from the back how to split it, so I get the count of the number of subarrays which are equal to the target sum. What I can do is I can start iterating from the front, right? So I'll start from the front and I'll check. Okay, so let's first have the array again, which was 1 2 3 0 3, 1 2 3 0 3, right? Now let's maintain a variable sum which is equals to 0, right? Now let's iterate from this array. So now the sum becomes 1. Okay, now the sum becomes 1, right? Now let's take a look at this S1. So now we are currently sorting out S1, right? Okay, so is it equal to my target sum? My target sum is equals to 3. So is 1 equals to 3? No. Let's move forward. Let's move forward. So now this becomes 3. Okay, this becomes 3. Now if this becomes 3, my S1 is sorted. S1 is equals to 3. Now I know the number of ways to split my S3, right? Where do I have that in my suffix array? So now what I can do is to get the number of ways such that I include this part and I include any part from the back. What I can do is basically that the current index I'm standing in, which is I, from here, I can go to I plus 2. Why I plus 2? Because I plus 2 would be this guy, right? So there are two ways of doing it. There are two ways of doing it, right? So my current answer would be equals to 2. Now the question is, why did we choose I plus 2? Because you also need to take care about S2, right? We have sorted S3. We are currently traversing and calculating S1, right? All we need to do is we need to care about S2. So why not I plus 1? Because I plus 1 will denote the S2, which is the sum of the middle subarray. Okay, that's why when you are iterating from the front, you go to the index plus 2 for that number in the suffix array, right? Okay, now let's move on again. So now the sum becomes 6. Is it equal to my target sum? No. Move forward. 6 only, then you have 9. So the answer becomes 2 here, right? So the idea was that you first sort out one part of the array. You iterate from the back and calculate all the ways of splitting from the back to a particular index I, you get the number of ways. Then you start iterating from the front, and to calculate the number of ways for any current index, you need to jump to I plus 2 for that particular index, right? Okay. So what is the time complexity? The time complexity for this solution is O of n. Since we calculated the suffix in O of n time, and now we are iterating and we are just moving 2 steps ahead. And what's the space complexity? It is also O of n for calculating the suffix arrays, right? Now let's move on to the coding part. Okay, let's code it up real quick. So we are given an array A and the size is n. So the first thing which I want to do is I need to calculate the total sum here, right? So I'll say total sum is equals to 0, and I'll iterate over the array and we'll calculate the total sum. And the first thing I'll check is if this is divisible by 3 or not. So if total sum mod 3 is not 0, if it is not divisible by 3, then just return a 0. What does 0 signify? That there are no ways to split such that the sum of all 3 partitions are the same, right? So now if there is a way, then I'll say the target sum is equals to total sum divided by 3, right? Now let's maintain a suffix count and mark all as 0 for now, and let's also maintain a variable current sum. Okay, now we'll start from the back. Okay, and we'll say current sum plus equals to a of I. Now if current sum happens to be equals to target sum, then at that particular point I need to mark it that at this particular index it is possible to have a split such that it is equals to my target sum, right? Now we have only marked it, but I need to get the number of ways, right? To get the number of ways, I'll again start iterating from the back, and this time I'll start with n minus 2 because I need to add whatever is forward to it, right? I'll say suffix count of I plus equals suffix count of I plus 1, right? So now we have gotten the number of ways from the back to split the array such that its sum is equals to the target sum, right? So now let's maintain a variable called answer to be 0 and sum as 0. Now I'll iterate from the front and we'll go till n minus 2 I plus plus, and we'll say sum plus equals to a of I, right? And if my sum is equals to the target sum, then we'll say answer plus equals to suffix count of I plus 2, right? Why did we only go till n minus 2? Since we are doing this and I don't want the indexes to be overflown, right? That's it. At the end you can return an answer. Let's run it. So yeah, the trivial cases are passed. We'll submit it. Yeah, so this is accepted. I hope you guys understood the solution. This was a really nice problem with a lot of optimizations involved, right? So I hope you guys understood the solution well. I'll meet you guys in the next video. Till then, take care. Okay, chalo, bye.